Welcome to 132nd episodes of this channel. So this channel now growing very fast. Now you have access to more than 130 videos of mathematics to help you revise for exams. If you haven't subscribed to the channel, now probably it's time to consider to subscribe it so you can access all those videos conveniently. So please take advantage of it just by clicking the bell, subscription bell. Doesn't cost anything. So, all right, thank you. Today we're going to discuss parametric equation for vectors. Then we also find a collision point. Okay, we got a parametric functions. Sorry, the vector position vector. So we only need to use one. So this question is partial questions. So the question we got RT, which is position vector RT. So positions RT is in the curve is in red. So that's a red curve. So there's a point, the particle A travels along this red curve. So this is the path of the particle is we need to prove in Cartesian form. So we need to convert from the vector form to Cartesian form to see if it's true. So how do we do that? First, we want to put x components separately. So x component is 1 plus 4, negative 1 plus 4 cosine t. Then y's become 2 divided by square root 3, then sine t. So this is called parametric equation. So we know if we're using the sine theta plus cosine theta square equal to 1. So this is the Pythagorean identity. So we can easily to convert cosine t is pi x plus 1 divided by 4, sine t is square root 3 divided by 2y. So sine squared t plus cosine squared t is 1. So therefore, we prove the Cartesian equation is true. So this is an ellipse. All right, so now we're going to continue to do the next question, B1. Now we need to show that we got another B, another point B is travel somewhere differently. So B is here, maybe in different curve. So this is the second function is called ST, second vector function. So this is a OB. So we want to prove those 2 points will collide eventually somewhere. So maybe B has to be in the same. So eventually those 2 points will be colliding. So in order to prove colliding, we need to solve for, if we can solve RT equal to ST. So if we can find a T. So when we equal 2 vector position vectors, so therefore the x component equal to x component. So we establish equation 1. Then the y components are using green. Y components equal to y components. So that's a green. So now we solve the first equation. Secant is 1 over cosine. So cosine squared is a 3 over 4. So cosine could be positive, negative. square root 3 divided by 2. If I solve with the second one, you can see tan changed to sine over cos. Therefore, sine cancel with sine, so cosine is positive. So we combine the two together, so there is a common solution is a positive. So therefore, the 2x component, y component, we can solve one solution, which is cosine t equals square root 3 divided by 2. So therefore, t is pi over 6, so that terms exist. So then we're going to find what is the collision point. So we by substitute the common t into the function pi over 6, substitute position r, position vector r, so then substitute, we will get, because you got 4 here, so there'll be 2 square root 2, then cancel 2 with 2. So final point, x coordinate is -1 plus 2 square root 3. Y coordinate is pi square root 3 plus divided by 3. That's it. So this is how you solve a position vector from parametric form to Cartesian form. Then you solve the common time when the two vectors will collide, if we can solve. Then we find a collision point. Thank you for watching. If you liked it, can you give us the thumbs up? I'll see you next time. Bye.